Hi good people, my name's Titus, and today we're continuing with part 3 of our Pong mini-series, where we recreate the classic arcade game inside Unreal Engine. In the last video we created the projectiles, and in this vid we'll work on implementing a game manager. Let's not waste any time and just jump right into it. Alright, starting off we will open up our game manager blueprint. To be able to edit the graph, we have to click on the Open Full Blueprint Editor at the top. From here, we need the game manager to do two specific things. We want it to, of course, track our player 1 and player 2 score, but we also want it to spawn the actual Pong projectiles. In the last video, we were spawning them through the player blueprint by pressing the spacebar, so we're basically going to undo that test code there. So let's get rid of the tick function, and on the event begin play, we can simply call in a delay. I'll set the delay for 1 second, and after 1 second we can do a spawn actor from class. Now the blueprint class we're going to choose is of course the projectile, which we named BP_ball. We have to give it a transform, so we can right click, split the structure pin, and I actually want it to spawn at world origin, which is 0, 0, 0 on the location. So this is actually perfect, so we're actually good with just that. Now for the second part of the game manager, we need to handle the scoring. So we'll create two custom events for that. The first one we'll call player 1 score. And the second one we can call player 2 score. And these will be pretty simple. We basically need variables to track the existing score. So under our variables tab, we just hit the little plus sign, and we'll call this one player 1 score. The data type I'm going to use is just going to be an integer, and then I'll do another one called player 2 score. Whatever name you choose, just make sure it's not identical to the events that you create, because I think that will give you an error message. When we compile these, we can then set the score. It defaults to 0, which is perfect. That's actually what we want for both. So when the event is called, we simply want to get the score and then increase it by 1 and then store it. The way we can do that is we can hold the control key out and drag in the variables. I'm actually going to move this a little bit higher. And then off the score, we can just simply come into an add node here, and then once we add 1 to the existing score, we can hold the Alt key, drag out the score, and do a set, and then this will work just fine to basically increase the score. Another way to do this, which might be a little bit cleaner, is we can delete these nodes, and we can come in what's called an increment node. So if I do ++, choose the increment, this will do those two operations in just one single node, so it's a little bit easier. So we'll do the same thing for this one here. And then after we increase the score, normally we're going to be sending this to a HUD to display to the player, but we don't have the HUD created yet. So to be able to see if this is working, we can just come into a print string. And then from the print string, we can pull off into an append node. And then for the top node, I'm going to call this one player 1. For this one, I'll do player 2. And we can just pass in the current value here. That way we can see if it's working. Now, if you remember on the projectile, when we call the score event on the projectile, it plays a sound, and then it destroys the actor. So basically the ball gets, completely erased. So when we score, we're going to need to basically create a new projectile. So we can simply use this spawn actor blueprint that we used for the event begin play, and we can press Control D to duplicate it. And then Control D again to duplicate it. And that way we're basically, every time we score, a new projectile is spawned. And you can add a delay in there if you wanted to as well. Now, if we compile and test this code out, it's not fully going to work. So you'll notice the ball will spawn, which is great. But when a player scores, we should see a print screen, and we're not going to. And then another projectile also does not spawn. So why is that? So we created the events to handle the logic for increasing the score and spawning the projectile, but we never actually call the events. So we need to figure out where we're going to do that. So we come back into our level blueprint. When we created our level, we added these two trigger boxes, which are basically just scaled up. And when the projectile overlaps with one of these trigger boxes, it calls some code in the level blueprint. So I think the best place is to put it there. So we can open our level blueprint here. Here's the two trigger boxes. When they overlap, they cast to the projectile, and then they call the custom event called score in the projectile, which deletes the ball and plays the sound. So what we need to do is get a reference to our game manager, and then we need to call these events for the game manager. So what we can do is we can use the begin play on the level blueprint, and at the end we'll do a simple cast to BP game manager. And then what we can do for the object, we can pull off and do a get game mode. Once we have the game mode in the cast, we can then right click on the blue pin and promote it to a variable. And we'll just call this our game manager reference. That way we have it stored, so we can call it pretty much anywhere. So in our custom event, we can drag out our game manager, do a get on it. And then if I pull off the blue pin, I can call any custom events from that blueprint. So we had the player 1 score, and then we have the player 2 score. Now you may be wondering why we have the player 2 event going on the player 1 trigger goal, and vice versa, the player 1 score on the player 2 trigger goal. Well, that's simple. It's because I made a mistake in the last video. If you notice, I named these player 1 and this one player 2 on the assumption that this cube was player 1 and this cube was player 2, but the camera's rotated and I didn't catch that, so this is actually player 2, as you can see in the graph there, and this one is player 1. So you can either invert it like I did, or you can move this one to this side and this one to that side, or you can rename them however you want to deal with that. But now if we play our prototype here, and I'll let this, that'll be a player 2 score. So player 2 has 1, player 1 will now have 1, and player 1 will now have 2. We can see the score is actually working correctly. So that's perfect. So the next thing we want to do is, there is a chance that when the projectile spawns, it'll spawn going basically vertical, like perfectly vertical, and it won't move really to one side. So we'll want to account for that possibility. You could do so a few different ways. Like you can clamp your angles on the construction script. Another way we can do it is we can, in the original Pong game, the projectile actually goes faster over time. So we can just do that, and then we'll just make sure it goes faster over time on the horizontal. And it'll slowly basically move to one side and kind of account for that. So what we have to do is open up our projectile, and then we need to create a custom event. So this one's going to be called, we'll go to the functions. Actually, yeah, we'll do it in a function instead of event. So with the plus sign here, and we'll call this maybe more speed. And then what we can do is, our static mesh is the root component, so we can drag that into the graph, and we can get the root component's velocity, or component velocity. You can then split the structure pin, so now we have access to the X, Y, and Z. If we go back to the level, you'll notice this little gizmo in the bottom left corner. The up and down is the X, and the left and right is the Y axis. So we want to accelerate along the Y axis. So I'm going to use the Y, and I'll do a greater or equal to. And then I'm going to hold the B key, click in the graph to add a branch node. And that'll be my first check. So I'm basically saying if the projectile is greater than or equal to 0, do this. If it's not, do this. So what we're going to do is we're going to drag in the projectile, the root component, and we are going to add an impulse. So if it's true, we're adding an impulse. If it's false, we're adding an impulse. And then you want to make sure you check the box for velocity change on this. Otherwise it won't work. So we'll go ahead and hook up our execution pins. And then I'm going to double click to add some reroute nodes here. All right, so now we need to figure out the impulse that we're adding. So I'm going to split these structure pins. Oops, I'm going to undo that. Delete and delete. And split, there we go. So basically if it's greater than or equal to 0, I want to increase the impulse by a positive value. If it's negative, I want to subtract the value. And that's just so the acceleration basically continues to climb. So we can count for the possibility of like negative values. There's a few ways you could do that, but this one's just easy enough. So we'll add a new variable. We'll call it acceleration. I'm going to use a float, compile, and then for the default acceleration, I'm going to start it at 100 units. And then for the positive value, I can just drag it in there, and it's good. For the negative value, I need to get a get reference, and then I need to multiply it by -1, and then pass that in here. Now that's great, and if we play this, it's not really going to work or do anything, but you can kind of see there. Doesn't really seem like it's accelerating, right? And that makes sense because we created the function, but nowhere are we calling the function. So we have to figure out kind of where we want to do this. And real quick, what we can do is let's get our root component. We'll get the component velocity again. We will split the structure pin, and on the tick code, we will print. This will be test code, so you can kind of see what's happening. So we'll get rid of this in a second. Now, we don't need overlap, but we do need event begin play. So when the projectile is instantiated, it'll call begin play, and we can do a set timer by function name. The function name has to match exactly whatever you call or whatever you name the function. In my case, it was more speed. It is case sensitive, so make sure you match basically identical. And then how many times do we want to, or at what interval do we want this to call that function? I'm going to do maybe 1 second starting off, and then I want it to loop. So now if we compile and save and we go back to the scene, you'll see in the left-hand side 1100, 1200, 1300. And no matter if the value is negative or positive, it's going to increase. So -15, -16, and there's 17. So basically the projectile is going to get faster and faster over time. And that'll basically account for those edge cases where the angle that the projectile spawns is basically near vertical. It'll over time just pick up. I don't know if I can get one to actually show. that one. So that one kind of starts near vertical, and you'll see over time it'll start moving sideways faster than it moves up and down. So that works perfectly. Alright everyone, we'll cut it here. In the next vid, we'll work on creating our heads-up display so our player can see the scores. As always, thanks for watching, consider subscribing, and we'll see you on the next one.